This guy ruined science for me. Albert Einstein. From my childhood, I've always been told how great Einstein was, how revolutionary his discoveries were. I probably read multiple biographies of Einstein, watched that kid's cartoon, rather predictably named Little Einstein, and marveled at his many, many discoveries. For me, Albert Einstein signified genius. The sheer magnitude and weight of his achievements both inspired and intimidated me. I was awestruck at words like quantum mechanics, theory of relativity, and equations like E equals mc squared, even though they were way too fancy for a 10-year-old and I had no idea what any of them actually meant. But in spite of my lack of understanding, Einstein, together with other celebrated scientists like Isaac Newton or Charles Darwin, embodied for me what I thought was the very definition of science, a long chain of magicians having spontaneously inspired eureka moments, their superior intellect coming up with sophisticated scientific ideas and solving humanity's greatest mysteries. And to many of us, that is our standard view of science. Simply awestruck at their amazing discoveries, we worship Einstein, Newton, and Darwin like they are some gods of science. So we equate good science with spontaneous genius. But isn't looking at science this way, through its greatest moments of genius and discovery, satisfying and picturesque, romantic even? After all, how ingrained in our collective imaginations is the classic image of Newton relaxing under an apple tree when he gets hit by that serendipitous apple. And bam, sudden inspiration strikes him. And bam, gravity is discovered. Or the picturesque scene of Darwin on his journey to the Galapagos aboard the Beagle, collecting and analyzing a specimen of finches, and bam, natural selection and evolutionary biology is discovered. Through these semi-legendary tales of scientific discovery, we soften the hard and pointy scientific formula into more friendlier stories. The less science-savvy audience can ignore the complexity of the scientific procedures that lay behind these discoveries and immerse themselves into the comforting waters of a more simplified version. Telling science through its most famous discoveries is a great tool to communicate both the beauty and utility of science to the most elementary and unfamiliar audiences. A reason why, most often, we come across these stories in children's books. And exposed to these stories from a young age myself, I too thought of science as just a collection of groundbreaking discoveries by inspired geniuses. Then, 2 years ago, I was lucky enough to get an opportunity to join a cancer research lab in a local university in Shanghai, and my naive preconceptions about science were shattered forever. At the time, working in a lab for me was like walking into the unknown. I had just completed my AP Biology class in my sophomore year. I had never worked in a professional lab, and I had almost zero knowledge about cancer or pharmaceutical development. But I was nonetheless super excited to enter this world of real frontline science, and that was beyond the classroom walls to play my part and who knows, maybe make some scientific discoveries myself and to leave my own mark in the scientific world. Now, obviously, I wasn't thinking that I would be curing cancer then and there, but I did expect to make significant progress, whether that was finding a new mutation that might be one cause of liver cancer, or perhaps figuring out how to target a cancer-causing protein using some sort of chemical drug. Maybe not the discoveries of the same caliber to Einstein or Newton's, but something of that continuum. And after all, up to that point, that was what I thought science was, based on the stories of my scientific heroes. I was about to get utterly disappointed. Nothing was more disappointing than something we called a small group meeting. In these weekly meetings, which took place at a very unglamorous, cramped room next to my lab, 10 or so of us would meet up to discuss our experimental results for that week. On my first group meeting, my heart was pounding with anticipation to see all of the exciting results from my mentors. But instead, what I found in these meetings were grueling micro-criticism sessions. It seemed to me that all we did was look at these crude black bands, which reflected the level of protein concentrations in our cells. Was one band lighter or darker than the other? Was it in the right position? And even when the results looked totally valid, someone would question their legitimacy. What if the cells were in a bad condition? Were the concentration of proteins consistent? What if that small step in your experiment went slightly wrong? Every one of the thousands of trivial factors that might have had some microscopic influence on the experiment was thoroughly scrutinized. I never saw anyone who could stare at these lines on one PowerPoint slide longer than my professor. Like, come on, could the width of these black lines really be that important? To say the least, my expectations were shattered. Instead of making discoveries that could potentially save thousands, if not millions of lives, I was stuck staring at meaningless black lines on a projector screen. When one of my friends asked me what I had discovered during my year in the lab, I was embarrassed because I hadn't made any. I often felt purposeless and disengaged in the lab, uninterested in the experiments, and even disillusioned with science itself. The burning passion I had to experience real-world science when coming into the lab was completely gone. I thought, was I wasting my time? What was the point if there were no great discoveries? Eventually, I started to get over this childish disappointment, though. As I started to get a better understanding of experimental findings in the presentations, and I started to present my own experimental results, slowly I began to see the value in these meetings. Once, as a result of typical nitpicky criticism from my mentor on one of my most difficult experiments, I tweaked my procedures to get a much more coherent result on a second try. And from that point onwards, I began to take every experiment seriously. I wrote and evaluated every procedure meticulously, and I repeated and repeated experiments until I could form a coherent conclusion about my research study. And a year later, when my mentor asked me the same question as my friend did, what discovery did I make in the lab? This was my resolute answer. In the lab, I learned that in the real world science, there are never any moments when somebody suddenly yells Eureka and runs across the university campus like some insane white-coated genius. The truth is much more prosaic. Dealing with sensitive cells, proteins, and chemicals is tricky, so we strive to execute every minuscule step perfectly. And nitpicky criticisms like that focus on the smallest, seemingly most trivial piece of microdata, are what helps us to get as close as possible to that perfection. Criticism is there at every stage of the scientific process, from evaluating experimental results to the mandatory peer review process when it comes time to finally publish your results, to engaging in mutual criticism and dialogue with other academics with different views or opposite experimental results to yourself. Never can scientists be satisfied with the results we get. Sometimes, unfortunately, there are always elements in our experiments that could be better. There are always more experiments that could be carried out to make our findings more reliable. There are always more directions for further research based on previous experiments, always more questions to ask. Scientists spend almost all of their time not in glorious discovery, but in soul-destroying self-criticism, tearing apart every aspect of their own work to seek out their own weaknesses. But while this process of constant criticism is sometimes frustrating and difficult, it's also what makes science so beautiful. It's what makes it so reliable and so trustworthy. It's what makes science the single most powerful tool in uncovering the truth in our natural world. When we glorify or worship scientists for the discoveries alone, that unique and ever important scientific process becomes invisible. It gives us a false and overly romantic impression about how science works, and it cheapens and distorts the painstaking work of scientists. So science follows the cliche. It's about the journey, not about the destination. It's about being meticulous at every step. It's about the determination to keep the repetitive work going, and it's about being critical all along the way. The discoveries that are so often revered and worshipped as humankind's greatest works would not be possible without a group of nitpicky scientists staring endlessly at black lines in a boring weekly group meeting. Recognize that discovery may be our ultimate goal, but progress is made by the meticulously critical scientific process. So next time when you look at this direct signifier of scientific genius, Albert Einstein's face, appreciate his greatness not for E equals mc squared, but rather for the millions of times he doubted his own theories, and use these doubts as fuel to drive towards his greatest scientific discoveries. Thank you.